So, today's lesson will be we're going to solve simple one-step equations. It's a refresher course for many of my former students / 8th graders, now 9th graders who still struggle. So, solving a simple one-step equation is kind of like having an x plus 4 equals 28. So we have one step. We have to get x alone. So we do the opposite of what this is saying, which is saying to add. So we're going to subtract the 4. So x equals 24. You can always plug this number back into this x over here. And you should get, when you plug it in, 24 plus 4 equals 28. So this is one of our simple, easy, one-step equations. Let's do a few more, just, so you can see how it works. Let's do m minus 23 equals -5. We should all know how negatives work, right? I would hope so. Hope you all know how negatives work. So what's the opposite of subtraction? The opposite of subtraction is addition. So we're going to add 23 to both sides. Okay? So m equals, and if you don't want to do -5 plus 23, an easier way to look at it would just be what's 23 minus 5. And 23 minus 5 is 18. Yes. It's 18. One-step equations are pretty self-explanatory. Just gotta move it so variable has to be alone. That's just how it has to be. Just saying. Right? I don't know if you're with me on this, but I'm with me on this. This is how this works. So what if we make it a two-step equation? So now we're solving 2 steps. We have 2 steps in it. Oh crap. Everyone freaks out when they see multiple steps. It's not even that bad. So now we're going to look at an equation that looks like this. 2x plus 6 equals 20. I'm making these up, so we'll do 26. Okay, 2 step. We need to get the variable alone first. Right now, it's chilling with this buddy over here. I'm gonna get rid of that 6. It's being added, so let's subtract it. Because now we're gonna bring this guy down here. So 2x now equals, because 26 minus 6 is 20. So now, but we're still chilling here with this 2. Let's just chill it with this x. I gotta get rid of that crap. So, the best way to do that is being multiplied, right? The opposite of multiplication? Division. Divide both sides. So whatever you do to one side, you have to do the other. Divide both sides by 2, and you get x equals 10. And we can take this, and we can plug it back in, and we can go, well, 2 times 10 is 20, plus 6, plus 26. 2 steps equations. So much fun. I like them. I just like algebra. So let's see if we have one. I'm trying to think of one. I have to do these off the top of my head. We're doing the fraction. Everybody hates fractions. I like fractions. Most of the time. Do 3 fifths a minus 10 equals, I'm trying to think of something easy. I'm trying to think in my head so I don't have to do too much work here. Hang on, we'll get this. And we'll just we'll wing it. It'll probably just end up being a fraction. It's fine. Oh, we'll say equals 40. All right. We're going to wing this one. It's going to be a fraction most likely. We'll wing it. I'm pretty good at winging things. Okay. Well, we have to get rid of this guy first. He's not connected. He's not directly connected to this 3/5, right? Just 3/5 is just so I'm going to add my 10. Okay, I'm going to add 10 to both sides. So now we have 3/5 a equals 50, right? Well, now we're going to get rid of this dude. This is where it's going to be a fraction, which I kind of wish I had done something a little different, but we'll keep it like this. So, to get rid of this, it's being multiplied, but it's a fraction being multiplied. So what we do is we're going to multiply each side by the reciprocal, which is basically dividing. So, I'm going to multiply both sides by 5 over 3. That. So you can put any number over 1. Like that. Cool, huh? Right? Whoop. So now this would go away, this would go away, and you'd be left with an A. That looks like a 9. Still looks like a 9. This one, a little harder to do, right? Because I can't do this in my brain. I can do it in my brain. My brain just woke up. So, 50 times 5 is 250 over 3. I like to leave it as fractions, but sometimes they want you to change it. And if we can simplify, it'd be even cooler. So let's see what we can do with this. Without a calculator, because I don't want to walk over to my table and get the calculator. I want to do this without one. So let's just see what happens if we can simplify this. If not, I'm not sure we can. We're just making this up. I'm showing you processes. So, woo. So I'm going to do a little bit of side work. I'm going to put the side work over here on the side. So, I'm going to do some long division. I actually like long division. I used to hate it. Little did you guys know, I failed math growing up and then went to major in it. Meh. All right. 3 can't go into 2, but 3 can go into 25, and it can go into 25 8 times. Because 3 times 8 is 24. I had to remember. And then we get 1. Bring down that. And then it will go into 10 3 times, which is 9. And I feel like we're going to be just getting a repeater here. Because we're going to bring this down. So decimal goes up. We're just going to get a repeater. So this can't simplify. We'll leave it here. And if they want it as a decimal, it's going to be repeating forever. Whenever. If they want it as a repeater, you'd have to do this. It's 89.99 with a line over it. But usually, I would just say leave it as an improper fraction. I try to leave them as improper. I don't like mixed numbers. Really hate mixed numbers. They're honestly one of the worst things ever. I always change all my mixed numbers to improper before I do anything with them in math. Just because they're easier to work with. So, these are 2-step equations. But I like 2 steps. I like multiple step equations. I just like equations, to be honest. So let's put it on a marker. put another one up on the board. I'm making these up again, so. Negative 7y. I don't know how this one's going to turn out, guys, because I just don't know. I made this up. Okay. So we have a negative 7y plus 144 equals 279. We need to get negative 7y by itself. So I'm going to subtract my 144. So these will go away. I'm left with negative 7y. So now let's do the subtraction here. I get a 5, 3, and a 1. This might actually work out. Without me realizing it, this might work out. Okay. Well, we have to divide by the negative. So right now it's being multiplied by a negative 7. So let's divide by a negative 7. Okay, so the answer we know will end up being negative. So I'm going to kind of ignore that right now. Just put it down here. So it's a negative answer. So let's do some math over on the side here. Oh, wow, my accent just came out a little bit. How many times can 7 go into 13? Well, once. One time. I have to think. And now 13 minus 7. 6. Let's see if it can go into 65. Maybe this won't work out. I'm thinking it would. I'm thinking. It will go in. It won't go in. Go in 9 times. 63. Yeah, 9 times. Yep. Back down. Hang on. I don't want to seem super embarrassed. Yep, 63. Okay, so that went in 9 times. Which is 2. Bring down a 0. Another decimal. Goes into 20. Oh, 2 times. Which is 14. Put down a 6. Which brings down the 0, which means this goes in 8 times. 7 times 8. I should know my times tables, but you know, they're not. My times tables are rusty, so I have calculators. I think we're going to get a repeater again. I'm pretty good at making repeaters, apparently. Because this goes down to... No, never mind. I'm doing math right. 4. Usually I would stop about here. Because this isn't going to simplify nicely, obviously. Yeah, we'll stop. So it won't simplify nicely, which is lame. So what happens when you don't have them written down beforehand? You just kind of make them up. So I'll just leave it as an improper fraction again. Negative 135 and 7. I know. You guys are probably like, what in the world? She majored in math and she can't do simple math. Well, there's some reason I can't do some simple math. Majored in it, but then got in a car accident. So I have a slight brain injury and lost a little bit of my memory. This is helping me gain my memory back, but I still struggle. There's a cat right here. Okay, so now let's do some more two-step stuff, but we're going to add the added stuff of inequalities. And they're not that hard. The only difference is when you multiply or divide by negative, it flips the sign of an inequality, and then it kind of throws people off. No. So, let's say we have 2x plus 10 is less than or equal to 14. It's really simple to solve. It's the exact same thing. We're just going to minus our 10. And we get 2x is less than or equal to 4. And then we just divide. It's the exact same stuff. But we have to add a number line into this. Because 4 divided by 2 is 2. So now we have to add a number line. So we're going to draw this really fancy number line. Look how amazing I am, I know. And I'm going to draw a line here, and I'm going to put a 2, because I know it's 2. And this is saying x is less than, because the alligator doesn't want to eat it. It wants to eat the 2. So it's hungry for this guy. So when it has a line underneath it, we're going to draw a circle, right? But it has a line underneath it, so it means it can be 2. So we're going to fill in. It means it's a solid dot. And it says x is less than or equal to 2. So anything less than 2 and less is to the left. How cool is that? Less to the left. And left is that way. I know my left and right. It's not really, but yes, less. So anything down here will solve this equation. That's pretty cool. I think that's cool. I don't know. You can use any number that way. It'll always solve this equation. So we could choose, so I could be like, well, I want to choose -8. So let's choose -8, and we'll plug it in up here. And we'll see if that is still a true equation. Right? So 2 times -8 is a, 8 plus 8. I know this. We do know 16. But it's negative. So -16 plus 10 is less than or equal to 14. -16 plus 10 is a -6. And this is a true statement. -6 is less than or equal to 14. So any number I put in down here will always solve this because it makes a true statement. That's what an inequality is. As long as it makes a true statement, then we're good. Right? Right. Cool, I know. Math is actually cool. I love math. It's dope. Dope, dope, dope. Okay, so let's do one that makes people freak out. Because they're like, oh shoot, I did it wrong. It's fine, you didn't do it wrong. Some people do it wrong, but we can fix problems. Math is fixable. People make mistakes. I make mistakes. I can't do simple math. It's fine. I can do complicated math because I love complicated math. But this, sometimes I write equations and I'm like, ah, crap, can't do that in my brain. Look at me. Hey. So, let's do one. I'm going to put my little sign here. And I'm only going to use a greater than sign. Not a greater than or equal to. We'll just do greater than. I'm going to do, let's do negative, I'm just going to -x, because that wigs kids out too. Minus 15 is greater than, 20. I'm making numbers. Okay, let's solve this. Right? I didn't write that too hot. I'm good. I'm staying in brain. Okay. I'm going to add 15. Right? Right. I'm answering my own questions because no one can really answer me. 20 plus 15, 35. But some kids are like, oh, I'm done. I got X alone. you didn't get x alone. There's a cool little friend right here. And he's like, oh, hey, I need to go away. I need to go be with my 35 because X is not fun to party with. He doesn't do cool things like 35 does, so can I go over to 35? So let's take him. So technically that's a 1. Did you know that there's a 1 in front of that X? I did. So we're going to divide by -1. Okay. That gets rid of our negative. But in inequalities, if you multiply or divide by a negative, this little sign right here will flip. You can add and subtract till the cows come home, but when you multiply and divide by a negative, that sign's going to flip. Okay? So now we're left with x is less than negative 35. Cool. The sign flipped. We divided by a -1. Dope. Now, number line. My lines are not straight, but I don't care. We're going to draw a little line here. -35. Okay. This says x is less than -35. There's no little line underneath of this as it's equal to. So our circle on the line stays open. You don't fill it in because it can't be -35. It won't make a true statement. So we're just going to not fill that in, and then any number, because it's always to the left. Ta-da. What? Please don't do that. It really hurts. So, this is an inequality. I like inequalities. Well, I keep saying I just like math. So, let's move on to something that also trips people up. And they get confused. We're going to move on to absolute values. What? Absolute values. I have an x plus 3 in an absolute value bar equaling, well, let's say 21. That's too high. All right, we'll try again. Sometimes I can't even see my own handwriting on my camera. Okay, so x plus 3 equals 21. And it's in absolute value bars. With absolute value, we actually have to do 2 equations because you have to take it out. So, here's my 2 equations. I do x plus 3 equals a positive 21. Hey, get down. Or not. And then x plus 3 equals a negative 21. You have to solve for the positive and the negative. Always. So now let's just solve them. Easy peasy. I'm going to minus 3. I like to solve them at the same time. It's just easier for me. If you don't want to solve them at the same time, that's fine. Solve them separately. Do whatever easier for you. So x is now by itself. 21 minus 3 is 18. Yep. Can do math. Negative 21 minus 3, that's adding because they're both negative, is negative 24. So now, we need to plug these back in. An absolute value means, this is just meaning how many spaces it is away from your number line. It's how many spaces it is from 0. That's it. People think, oh, it always has to be positive. My cat just got stuck in the dollhouse. That's hilarious. Anyway, So it always has to be how many spaces you are away from 0. That's why it's positive. So if we plug this in, 18 plus 3, take the absolute value of it, you get 21. If you do negative 24 plus 3, 21. That's how many spots away from 0 it is on the number line. You always have to do 2 equations. So now let's throw a wrench into our plan. And I have made this mistake before, and it was really embarrassing because I made this mistake in front of a bunch of students. And I solved it, and then I looked at it and was like, I just did something super dumb right in front of you guys. So don't do what I did, because it was really embarrassing. I was like, I just solved this for no reason. So let's do this. We're going to do okay. Well, I'm seeing stuff right here off the bat. Because if I were to take if I were to do this equation where I did it last time, or I'm going to take them like this and split them, where I have 65x plus 35 equals negative 55, right? Our problem here is, if I were to minus 35, it's going to go more negative. We cannot do an equation, an absolute value equation, if it is equaling a negative number. If you see something like this, and it says minus 55, guess what? No solution. Don't try to solve this. It's no solution. It's negative. You can't solve that crap. Trust me, I tried once, and I just sat there, stared at the board, kept going, and was like, this is not going to work. And the kids stared at me like, what are you doing? Oh, embarrassing. But here's a different way to look at it. Let's write a different equation and see what's going to happen. So if I'm given this equation, though, because right here I'm given a different kind of equation. Yes, it's equaling a negative number, but I have to get rid of this first. So if I get rid of this first, because I can't pull that absolute value yet until I get rid of this extra guy over here. I'm still with my absolute value of 4x. But now negative 4 plus 8 equals 4. So now we can actually solve this absolute value because it's a positive 4 now. So let's write this. 4x equals 4. And 4x also equals negative 4. See? Something we can actually solve. We divide by 4. X is actually going to equal 1 and negative 1. That is something you can solve. You always have to make sure you're looking at the equations, because the other one had the absolute value of this, something like that. You can't solve something like this. But you can solve something where it's on the outside of the absolute value, and it makes it positive again. Right. It's pretty cool. If you ask me, that's cool. So, those are simple equations using inequalities, absolute values, one-step equations, two-step equations. Kind of just a refresher on those for a little bit here. I'm going to try to get some graphing stuff because we have to go into that. Do some slope tomorrow. hopefully you find this helpful, as we're not in school right now. Find the refresher helpful.